The chain rule is a powerful tool for finding the derivative of composite functions. So we have a function that we're splitting into two parts. We have the outside part that we're going to take the derivative of, and we have the inside part. So as we look at these, we want to keep in mind that there's an inside, there's an outside, and to find the derivative of the overall function, we're going to just multiply those two derivatives. That's the key. So let's start here with the sine of 2x. Well, we have an outside and an inside. Sometimes parentheses here will help. So this is the inside, or the u, which is the inside. So we can say that if u is 2x, then the derivative of u with respect to x is 2. And we're saying, well, then this whole thing is just sine of u. And so dy du is, derivative of sine is cosine of u. All right? Or we can rewrite this as the cosine of whatever u is, which is 2x. Now, we won't always write these steps here, but maybe I'll do it the first couple times just to help us understand. So using our rule there, our chain rule, dy dx is the derivative of the outside times the derivative of the inside. And so, and those can be in different orders, and at different times we'll do inside first and outside second, or whatever order seems best. So this is 2 times the cosine of u, but instead of writing it as u, let's go ahead and write it as 2x. And there it is. So you can see we took the derivative of the inside, that's here, and then we took the derivative of the whole thing by ignoring the inside there. So we kind of just ignored this and said the derivative of sine of blue blob is cosine of blue blob. And then we said, well, what is that blue blob? And we got rid of that. All right, let's cruise on to another one. How about y equals tangent squared of x? Well, first thing we want to do here is we want to realize that this is really y equals the tangent of x squared. So now we have the inside and we have the outside is u squared. So if we say the inside u is tangent of x, then du dx, derivative of tangent, is secant squared. And so we can rewrite this as u squared, because I just redefined that. So dy du is, well, how do you take the derivative of u squared? That is 2u to the first. Okay? And so that is equivalent to 2 times u. What is u? U is tangent of x. So to find the derivative of y with respect to x, the chain rule says multiply these things. So we're going to take these guys here, secant of x, 2 tangent of x, and multiply them, our two derivatives. So we have 2 tan x secant squared. That's it. Okay. All right. How about this one? Well, there's our inside. So we got our inside is x plus 1. Okay, so we can try this. If we just focus on the x plus 1, I'm going to zoom out so that all you see is x plus 1. Okay, so we can start to do this together. So take the derivative of that. That's our inside. So the derivative of the inside is 1. Now, just kind of ignore that. Don't, imagine that this is just a blue blob. So we have 1 over blue blob, all right? So 1 over blue blob is going to be, this is like blue blob to the -1 power. Remember that? Okay. You could use, well, you don't want to use the quotient rule here. All right. But we got this to the -1 power. So how do we find that derivative there? Well, to find this derivative, we take the -1, we're going to drop it down and get -1. We're going to subtract 1 from that exponent, -2, just using the power rule there. And then we take whatever this blue blob is here, and we're going to drop it down. Well, the blue blob is going to be x plus 1, right? So, all right, so this is kind of a cover-up method there. So we just kind of, we take the derivative of the inside, then we just kind of cover up the inside and take the derivative of the outside. Now we'd like to clean it up a little bit more there. And so we don't care about that 1. We got this -1. We want to write this with some positive exponents here. So that second power, we want to drop that downstairs as x plus 1 squared. And it's -1 on top. So -1 over x plus 1 squared is our derivative. Derivative of the inside times the outside, and then we're going to clean it up. All right? Well, this one's got a couple steps because we've got a product rule now. So let's kind of bring it all together. First, we got the product rule. Product rule says derivative of the first. Derivative of the first is 1 times the second, which is the secant of x squared plus x plus 1, plus the first, which is x, times the derivative of the second. Well, the question is, how do we find the derivative of the secant of x squared plus x plus 1? So the challenge is going to be to find the derivative of this part right here. So that's what we got to focus on now, the derivative of the secant of all that. And then we've got it all. So we're going to need to use substitution here. So we've got the derivative of the inside. Here's our inside. And then we got the derivative of the outside. And we want the derivative of the inside times derivative of the outside. Okay, and I got my handy thumb here we'll use in a second. So we've got all this stuff. Let me copy this stuff down here. We don't need the 1 out front there, of course. And then we just need to find the derivative of the rest here. Well, the derivative of the inside, let's work from the inside out. A lot of times that's easier. So that's going to be 2x plus 1. That's the inside. Now what we're going to do is this. We're going to take the derivative of the outside, which means we're going to kind of ignore this. So here's my thumb. I'm going to put my thumb over this. All right. There we go. We'll just kind of cover that up. All right. So how do I take the derivative of secant of whatever's under my thumb? Well, just ignore the fact that there's stuff under there. I've already dealt with that. Derivative of secant is secant tangent. So secant is the one that doesn't want to go away. So secant of blank, tangent of blank. And now, well, what is that blank? Remove the thumb, and we have x squared plus x plus 1. X squared plus x plus 1. Oh boy, that's huge. But that's it. Look at that. You found the derivative dy dx. That whole thing there. Now, when we're doing an application problem, we'll probably want to clean that up a little bit. In fact, what we probably want to do is factor out this secant of x squared plus 1. I'll go ahead and do that for good practice here. Just to make it a little cleaner, secant of x squared plus x plus 1. And that leaves, because I'm factoring that out, the whole thing of 1 plus, and I have this x, this 2x plus 1, and this tangent. So x, 2x plus 1, and tangent of x squared plus x plus 1. So that's one way that will simplify that, but it's fine. We don't need to worry too much about simplifying right now. All right, let's look at a couple more using that chain rule. This one actually has a few parts to it. So we have, let's highlight them here. We've got 5x. That's one part. And then we got the 5x there. Then we have cosine cubed. That's another function. And then we have this secant of all of that. Okay? Different color. And we've got this whole function. So we got a whole bunch here. All right, let's rewrite this a little differently, just so we can see those layers, those onion layers. 4 minus, and let's write this as cosine of parentheses 5x cubed. All right. So we're gonna take the derivative of the innermost and then work our way out. So dy dx. Okay. So we're gonna start from the inside. The derivative of 5x is 5. Now let's go to the next level. Let's talk about the cosine. That's kind of the next level out. So we're going to multiply. The derivative of cosine is sine. And it's the sine of that 5x. We've already dealt with the 5x, so we don't need to do anything. That 5x just continues. We've already dealt with that. Now, let's deal with this cubed thing going on here. So we're going to take the derivative of this whole thing, which let's pull out our thumb. Don't get distracted by the stuff that we've already dealt with. We've already dealt with that stuff inside. So we have 4 minus thumb to the third. 4 minus thumb to the third. How do I take the derivative of 4 minus thumb to the third? Well, the derivative of 4 is 0. Then we have minus thumb to the third. Well, the 3 is going to come down and become a 2. We're using our, what are we using? Our power rule. That's what it's called. Okay. And then, well, what's under the thumb? Let's copy that down. Cosine of 5x. All right. Oh, boy. Then last but not least, we've got the outside here, which is the secant of all of this. So we'll just kind of cover that up with our thumb. And so we got the secant of that. Let's shrink this and move it around. Need a little more room. So this whole thing on the outside would be derivative of secant, which is secant of blank times the tangent of blank. Well, what is that blank? Well, whoops. Got some issues here. All right, so what is that blank? It's going to be 4 minus cosine cubed of 5x, and that goes in both these places. All right. So there it is. Huge, ugly, but one step at a time, we can make our way through it there. Start from the inside and work your way out, and you'll get through it. Okay? So that's a super problem. Don't expect that problem on any assignment or test there that big, but I wanted to show you that how we can go as many layers as we need to. So last one here, let's finish off with a more reasonable one. We've got dy dx. Let's start from the inside out again. Take the derivative of the inside. That's going to be a quotient rule. Quotient rule says derivative of the top times the bottom minus the top times the derivative of the bottom. Derivative of the bottom is 2x. All over the bottom squared. All right, we got the derivative of the inside taken care of. Now we're going to take our thumb. Let's grab the thumb. Okay, and we're going to take the derivative of that stuff squared. Well, ignoring what's on the inside, when we have our power rule says drop the 2 times the inside to the first power. And what's on the inside? Well, we just copy 3x minus 1 all over x squared plus 3. And there you have it. That's the derivative. So, hope that helps. Just working in layers there, like an onion or an ogre. So the derivatives, the chain rule just says take the derivative of the inside times the derivative of the outside, and you'll make it out. Multiply them together.